Hello, Jakob. It's good to see you again. And of course, I'm here on another continent. This is just amazing. The technology allows us to do this. Just continuously blows me away. I mean,
Indeed.
hey, Dick Tracy, suck this up, man.
Well, it's not as impressive when you start looking at the predictions of sci-fi in history, especially movies and stuff. We are horribly behind when it comes to the jetpacks and flying cars and all of that fun
Snow
stuff.
crash.
Oh yeah, we're definitely more on the dystopic direction. Anyways, we left off last week with I would say some fairly deep delving discussions, and you of course picked up the mantle and did a very nice long description of your own take and model of solar formation. I think this is the takeaway. You and I have been kind of on and off talking about these things for many years now, and I think we have almost a decade of friendship behind us. But it's always been the same thing, and it's only now with the new data that we picked up the torch and decided to try and put some ideas out there. I think we are both sensing that there is this potential paradigm shift coming very soon, and of course, the first spark is going to be coming from the type of data that we're getting from the James Webb thing. But I think that's only going to be the nudge that wakes up all the sleeping giants, because as I kind of mentioned last time, it's not like there's not controversial ideas, concepts, theories for all of these things. They are there and they have been coming out. They've just been shut down because there was not that burden of proof required available, right? And many of these things cannot be done by individuals. I think that's the real handicap about modern astronomy and modern theoretical physics, that we are no longer in the era of Renaissance men and Enlightenment and the late Enlightenment and early industrial phase of society anymore. Individuals can have many strong ideas and bright theories and stuff, but it requires collaboration today, and it requires quite considerable collaboration. So we need sets to collaborate in their specific pockets of ideas, thesis, and how to approach building new models, new concepts. And we have to start from scratch, because I think that the data we're getting is showing us that a lot of our assumptions are based on nonsensical, very antiquated stuff, and it has been stuck in what they even admittedly say is kind of circular arguments. If you go and listen to some of the names out there, things like the people in quantum gravity, people that play with string theories, people that play around with the eight symmetry theories. There's many things out there that are on the precipice of tilting and tipping over these stupid old cows, because it is circular arguments, and there is no way around the fact that if you keep arguing like that to defend your position, this is not going to work in the 21st century. It's just not.
No, I agree.
People are not that gullible anymore. You can't just wrap people into these loops of circular argument.
Yeah, I think you're right. You have to show in this day and age, if you're a heretic and you're out there, you've got to the burden is on you. You have to show observations that support what you espouse. And if you can offer a laboratory experiment that can verify it, that's what I will listen to. That's what I want. But I'll go for, if you are basing what you're saying on a series of reasoned observations, I'm all ears.
Well, I think my observations are always based on, well, basically biomimicry and the fact that nature is my guide.
Absolutely.
It's what shows me how phenomena in the universe seems to behave, and I have not seen any exception to the rule, maybe with the one exception of one of my countrymen that came up with quantum mechanics. And I still think that we are down a rabbit hole of well, smoke and mirrors. It's the nature of the beast that, because of our limited range of seeing into these realms, right? I think I touched upon it when I said that you can't measure things without precise measuring tools. And when you're measuring things as inferred as particle physics and quantum mechanics, you're always many steps removed from the actual data, right? The data point. So how are we working with these things is all models. It's all based on if this is the behavior, this will be the expected result. And it's so many permutations from what you would call old school empirical data. And that's not what we're doing anymore. And the fact that science is still presenting itself as if it is a big lie. It bothers me when people think we're still living in the age of an Isaac Newton poking his eye or anything else as tangible when you're talking about experiment. That's just not what's happening. It's way more complicated, and this is where it requires collaboration. It requires groups of people to come together and come up with these things. And I feel like what we have now is a model that is both antiquated and simplified. And they don't want to change it because they know how much work is required. This is very related to my pet peeve when you're talking about engineering, that we have tons of plasma physicists and theoretical physicists and nuclear physicists that are hammering away on a fusion model that is bunk. If it was anything else, this would not have been allowed to continue. The amount of money being thrown at this is like ridiculous. I think if you called up some of the guys from Skunkworks, they would tell you if someone was trying so hard to do something like, let's say, anti-gravity flight, well, someone would have stopped them by now, because if you don't have the theoretical model that can actually be verified, and you keep trying to do something that is provably not possible,
yeah, I think it's one of those.
Must be wrong.
I think it's one of those times when where alchemy is actually worthwhile. You know, the what would happen if we did this? The problem with large organizations that create tokamak reactors and stuff is because, and this is a bit of an anathema to what you were saying. I mean, large groups of people, yes, you do need that. How would you have created the James Webb Telescope without that? Absolutely. But if you have something like a fusion reactor, and you're building a huge fusion reactor, you don't really, you don't really know if it's going to work. And I bet you if you took a vote on the people building it, I bet you that 3/4 of them said, "Nah, this thing ain't going to work." And it's one of those moments in time where we didn't take the time to do experimentation. From the advent of the nuclear bomb and the idea of controlling that power, they went straight to the drawing board, and they started to draw out what they thought was something that was controllable. And lo and behold, they discovered, well, it had actually been discovered a lot earlier, but discovered plasma behavior, which plasma configurations are just so are not understood at this point, to the degree that building these monstrosities and expecting them to work, and like fiddling with, oh well, here comes a plasma configuration, but we can undo that knot with our computers. Well, it's kind of like the World War I airplanes like that were firing through the propeller ungeared, and shooting their propellers off. In fact, I believe the French guy who invented that system ended up behind German lines with a shot-off propeller. Well, that kind of sort of a approach to to building these monstrosities just doesn't pay off. And I could go on this for quite a while, but I'm going to hand it back to you, Jakob, because otherwise I'll just be talking in circles.
Well, I think my argument here is that we need to convince more scientists, and again back to the scientists in set, to at least start trying to ask the stupid question: if it's not this, what could it be? Let me give you the obvious example, right? If I was talking to a plasma physicist or any scientist really within physics and astronomy, and I asked him, well, do you think sonoluminescence is fueled by fusion? Of course he would say no. It's not a fusion reaction in the center of the cavity that drives the light, right? That's not what's happening. It's the ambient effect. So, and it's the same with something like, no one would say that a lightning bolt when the plasma pinches and gets excited, that's driven by fusion.
Well,
you could ask, maybe
you should
it
mention
cause
that. I've been reading a fairly recent articles that electrical discharges, and I think maybe even less than a Z-pinch, are producing gamma rays. And they're saying now thunderstorms, before they just thought they were just benign, like far below the the spectrum of dangerous levels, are actually able to produce those. So anyway,
and again, but they're not fueling it. No one would say that it is the fusion of hydrogen that makes a hydrogen bomb go off. That's not what's happening, right? And it's the same premise here. What if we ask the question, what if fusion is not the engine of the sun, but the result?
Yeah, I mean, I'm totally on board with that.
My point. If you considered, if you just for the sake of argument thought about this as, okay, let's play with the thought experiment that the local heliopause and the environment further away from our solar cavity, right? What if that is the ambient location that creates the sun?
Of course,
what if the sun is
what you see is what you get when you're looking at all the radiation that's coming through from the sun, the neutrinos that are coming from the sun. It's not coming from inside the sun. It's coming from what you can see. Everything that you don't see, you can only see through the sunspots and see these huge magnetic fields belting out of there. But that's not where the radiation is coming from. The radiation, as you correctly point out, the radiation is coming from the shell of the sun. It's that simple.
And the point here is that if we're onto something with the fact that the stars are actually just like big sheaths, big bubbles of plasma in space, then the direction to look in, especially this is where I kind of agree with the Electric Universe guys and a lot of the almost woo-like plasma physicists, that you have to then revisit the whole premise that when you have sea pinch and when you have glow of plasma, well, that's a linear effect. Now you just have to take your little brain and try to go up a dimension. So instead of a line, it's a brain. It's a sheath that's glowing because of the balance between inner and outer forces. So
Yes.
so this is your pinch. This is your sea pinch. It's just happening in a big membrane instead, right?
Yeah.
And if that is true, then you have to start looking at how does that happen, because then something must be going on between the ambient environment all the way out to the heliopause and into the surface of the star. So what is it that makes it do that? And then you explained the whole vacuum cleaner, the stellar system moving through space and actually acting like a hoover and sucking up material while it's moving. All that is the type of direction we need to start looking, because it's all, the problem all comes down to the fundamentals of what I think is dimensionality problems. I know that there's some theoretical physicists and mathematicians working in topography stuff and all that high level math. They can do this. They understand this whole thing with the difference between 3-dimensional space, 4-dimensional space, 5-dimensional space. What is the nature of shapes of 4 dimensions showing their shadows in 3-dimensional space? All of this stuff they understand and can deal with. But I don't get the feeling that normal astronomers do that.
Yeah.
And not even plasma physicists. They don't think like that. They're more like engineers and observers. They think about, okay, that's a sphere. Well, what is the nature of a sphere mathematically, topographically? How does that work? How does these things, what, as I said to you, one of the things that gave me headaches was when I went from understanding how fractals work in a normal plane, when you just graph it on a piece of paper or on a screen, that's fine, easy 2D, I can understand that. But what is the equivalent when it's doing that in a 3D environment? What is that level of fractal like bifurcational branching in 3D? I still don't really have a good grasp of it, because it hurts my head to try and imagine a higher dimensional fractal of any nature.
This is where I'd like to interject for a second. One of my fascinations that you have sort of brought out that I'm very curious about. I've always been interested in helioseismology, the basically the sound of the sun, these highly organized waves that appear on the shell of the sun. And I've always been absolutely intrigued by the imagery that you've found and that you talk about. If we could go in that direction for a while, and if you've got something you'd like to show, I would be all eyes.
Well, I think this is back to, I think, did I show you some of this the last time? I was explaining the guiding wave principle and the emergence of quantum mechanics and the singing bowls. I think I want to show you that for a second, because I think that's still relevant to what we're doing.
Doesn't matter if it takes time to find it all. We can always edit that boring search part out before you get it onto the screen.
Well, I think this is the the one that I'm referring to. Let me just where did my thing go? Oh, it went over here. So I don't know if you can see this properly.
Oh yeah, it's coming through loud and clear.
The interesting thing about the singing bowl thing.
Jakob, why don't you expand the image so it's full size?
Like this. So what you have here is a very detailed experiment done with vibrations of bowls and the whole singing bowl example. And of course, you talked about this with shells. This is really the reason this is important is because this is about coalescing periodic waves towards a center. So
it's sort of like it's sort of like it's going out of phase, in phase and then out of phase. And when it goes out of phase, it produces those turbulent bubbles.
Well, it's because what seems to be happening is this thing that is related to fractals. You have waves that are coalescing and crashing towards each other, right? You can consider this, think of it as ambient radiation coalescing around a sphere, right? In this case, it's just a circle. So this is just the 2D version of what I am trying to wrap my head around. So when these oscillations, when these waves start interacting, what they're doing is they're not just going to behave like nice waves on a piece of paper, because this is in the medium, a medium that actually has surface tension that brings about the emergent quality of self-referential behavior, where it's not just drawing the interference pattern based on waves that don't do anything except just pass through each other. It's more complicated than that. They are additive. They are additive in a, as I said, self-referential and elastic way. So what then starts happening is that then the emergence of chaos, of course, you can start looking in detail, and you could maybe come up with some fairly decent, I think you would have to do some Lorentz transformations and emergent chaotic interference. The point is that what you see is that it starts being, it becomes decoherent, right? So what it reaches its maximum where it then starts splitting itself apart. The waves can no longer stay in the surface, and then you get the bouncing particles at the center. You see them here, right? You will see them there at the center. They start emerging as these little bubbles that then become stable and actually stay as bubbles that are bouncing. And this is back to the pilot wave experiment. You can basically tease these to come out if you disrupt the periodicity of the microphones from the edge. So you can just like twang the edge, and it will actually appear spontaneously as it's.
So I've got a question for you. So if you saw this on a larger scale, and I'm thinking in terms of, I think of the sun as a magnetic bottle upon which the shell rests, and I'm looking at these bubbles, and I'm thinking, would this be on a scaled up version? Would this be kind of like the sunspot activity?
No. Actually, well, that then would happen later. This is more like, if you think about the helioseismology that is happening with these standing waves, that's literally like your microphones playing these periodic sounds into the cavity. So this is basically what I am expecting. Something very similar is happening inside the sun, and again also on the outside, because you kind of also have to model the opposite of this, which makes it a little bit tricky to do experiments with. So this is the waves coming towards the sphere, right? You will also have waves going away from the sphere. But the thing that happens inside this is that they can't interact in a stable way. So you basically get, I keep calling it the Maxwell's demon. This is how you up-qualify high entropy energy to lower entropy energy. You basically you're getting energy for free. You're getting it up-qualified for free. So the way that you're getting this energy is basically how the ambient available energy is up concentrated and captured, and the effect is that you have energy coming from the outside and energy then coming back at you from the inside, and it basically joins at the vibrational layer, which then become the actual photosphere. The photosphere is like a plasma shell that is the equivalent of your bronze bowl in this experiment. It's the one that creates the vibration and the stable balance point between energy from the outside going in and energy from the inside trying to get back out. So this would be like when you have the C pinch thing, that's basically a vorticular motion, right? It's something going from somewhere where there is more of something down to where there's less. So then you get that vorticular effect, which is trying to equalize the two, and that can then lead to things like, if it's electrons, it leads to things like lightning, right? And that then brings on the whole plasma and the C pinch and all the things that we know from these dual spirals that then crush each other, basically. But this is the same thing. It's just a higher dimension. Instead of two strings, you have a double layer of plasma. You almost like you have with cells, right? You get this when you have a soap bubble. You have an outer and an inner layer that basically supports itself, right?
Do you have any of your images available, or videos of your of drum heads with particulate matter being oscillated by sound and creating those varying patterns? I found those quite compelling.
Oh yeah, okay. But you're talking next step up, which is about how the nature of cymatic patterns are formed.
The reason I mention them is because in helioseismology there are several interlacing oscillations that occur that have their own period. Like one oscillation is almost exactly 5 minutes. Like I remember back 10 years ago when they were looking at that, the astronomers were quite amazed. It was so close to so precise to 5 minutes. Of course, not necessarily any correlation with anything, but it was just fascinating that they have these interlacing oscillations that occur, and I think that your drum heads show this so well.
You're thinking about things like this.
Yeah.
You're thinking about cymatic patterns like this, right? And here you have the example with the non-Newtonian fluids. And here with
yeah, that one's fascinating.
With magnetism. The thing is that from what I can tell, what is missing is the higher dimensionality stuff, right? it's taking these things, because these are just the two-dimensional representation of what I am very sure is actually happening in 3D in space. And we have all the hints, all the directions. Someone just needs to put these things together and try to do what, well, put a fraction of all that tokamak money onto in my opinion, a Polywell or Farnsworth Fuser-like model instead. Get back to the garage with this science, because what you ended up with is wrong. It's based on extremely antiquated models, all based on exploding things and burning things at higher and higher temperatures, and that's just not really what's happening. That's a side effect. The sea pinch is an effect of ambient an ambient event. It's not it's not at the center of the lightning bolt that things are happening. It's happening because of the surroundings, and I'm pretty certain that that's going to be proven to be the same case with stars and most stellar phenomena. They arise. The sun is glowing because of the heliopause. The heliopause then becomes part of the balance between the surface of the sun and the chromosphere, and then the solar wind then pushes it out. So the cavity size.
I read an article a couple of days ago that every 200 million years, which is roughly the time it takes our estimated time, I wouldn't hold a stopwatch to it, time it takes our solar system to orbit the Milky Way galaxy, that there is an observed geological change that occurs on the planet during that trip around the sun. And one of the things they were speculating was that the sun is actually going through a denser area of space where there's more particulate matter that is pouring in to, the sun, the solar system's digestive system. I mean, you look at the rings of Saturn, and they're not fixed. This is a dynamic system. There's basically those rings go all the way down to the gravitational pull at the equator of the planet. It's a digestive system of sorts. It's basically
almost, and this is again why I keep
like a record player almost.
Well, this is why I keep coming back to Teilhard Lischerding and his cosmogenesis thing, and pretty much saying that even the universe on that scale is almost like living organisms, and that's really also how I see them. A fascinating thing is that this ties directly into what I call my personal theory of the formation of planets and non-glowing stellar bodies, right? So if the model that you and I adhere to when it comes to stars is correct, then you basically get this. Well, I know that you get most of the stellar cavity will be emptied of matter as soon as the star turns on. Of course, you could then start talking about accretion disks and stuff like that. But the accretion disk is a thing that is potentially always there, right?
Yeah.
But the important thing here is, as soon as any material hits the center of our solar system, i.e. the sun, all that material will basically be vaporized and flung back out, right?
Well,
but even that will try to
hang on a second. One of the things that I found interesting as a younger man, this is back when televisions, the old black color televisions, had a lot of static dust build up on them. You remember that time. You were old enough to have one of those TVs. I'd been, we'd had a party at our house. And the next morning I came down to watch the news, and there's a bunch of helium balloons that are like bumping against the ceiling. So while I'm sitting there watching whatever it is on television, the strings from the balloons, I'm taking and putting like something on it. I don't know if it was chewing gum or something. So they would balance perfectly in the air. They wouldn't go up to the ceiling and they wouldn't sink down to the floor. And I sort of did this to two or three of them. Then I forgot about them. I'm watching the television. And as I'm watching the television, from behind me, this balloon slowly makes its way over to the television and bumps against the TV. So I push it away. I didn't think about anything about it the first time. I pushed it away, sat there. A few minutes later, another balloon comes up and hits the TV. And I go, wait a minute, what's going on here? And so one of the things that I'm now going to jump out into the bow wave of our solar system. So imagine you're just a little cute particle floating around in space, and along comes this magnetic field, a heliosphere, and smashes into you at a speed that would make a bullet seem like a snail. And it knocks electrons off of your little dust particle, and it has a static charge now. Now that it has a static charge, that magnetic field becomes a digestive system, in that it's going to start pulling into your north or south polarity of your heliosphere, and there you have it. You've got a method. This would be the non-gravitational method of pulling in, like a baleen whale going for krill, pulling in the particles, which I suspect is probably the vast majority of what a heliosphere will pull in. And then, of course, there's the rocks and stuff, which that's where gravity comes in and does its pull. Of course, we always talk about the Oort cloud, and I've not seen it yet. It's supposed to be there. We have seen a few objects floating around. In fact, Pluto, I forget, the Pioneer. I'm not quite sure which one it was that flew by Pluto, also went by one of these objects out there. So there's this repository of food out there that's available.
Well, and the feeding thing aside, and making the solar system a big whale, almost like a bodying whale feeding on krill. Aside from that, I think the important thing for me is that I really want us to get away from that. Again, it's this beginning and end like way of thinking, where we think that at some point everything was glowing in and around the sun, and then everything started coalescing and collecting into these small rocks that then eventually just got these nice orbits, each at their own kind. It almost sounds like something taken out of the Bible, language-wise, right? Like the heavy stuff there and the light stuff out there, and it spontaneously,
mechanistic,
automatically. Yeah, it's a very mechanistic. It's a very God as a watchmaker like scenario, and it fits very well with the faith-based and the biblical types of thinking. My argument is just that that's just not really how biological systems or how the universe seems to behave, at least not to my knowledge. It's way more chaotic, it's way more generational, it's way more birth, death, and then in stages of growth. So when I was trying to revisit this whole scenario, I went back to, well, what if it's not like that? What if it's actually something that is continuous and generational? What if stellar bodies are not just formed and then just park themselves in nice orbits for the rest of eternity? What if they're actually born? What if they're actually emerging from the closest orbits of the sun and then evolve and grow and actually move out and then change their nature each in these phases. This is back to, well, they are almost like parked.
Yeah, yeah.
But,
you know,
they're
when I
parked
was
when they reach a balance point. This is back to the cymatic stuff, right? So when a certain collection of matter has a certain size, it wants to be at a certain orbit, and it will be parked there. But it won't stay there, because what's going to happen is, as it parks itself in this orbit, it's going to evolve. It's going to pick up more material, and it will do so again. I call this the cotton candy model. The material that is fed into the sun is like the heating element in a cotton candy machine. It will keep throwing out all this material in chaotic directions. But as soon as you,
I mean, I would hasten to add real briefly, the northern lights and the southern lights, the aurora borealis is basically a manifestation of, that's not material being blown off. That's material coming in as in particulate matter, you know. So it's definitely a dynamic system we're looking at. When I was a younger man, I speculated about the Voyager space probe had just gone by Jupiter, and looking at those moons, I was entertaining the idea, what if the red spot is kind of like a sort of a primordial Io to be, that occasionally, every couple of 100 million years, the Jupiter spits out another moon. It would strike me as not an entirely impossible idea. No evidence of that, purely a speculation. Okay.
Well, the reason I think this model is actually more useful is because it kind of explains how things can be, as I call it, generational and actually change, and that the stellar bodies, the planets, are not necessarily the end all. It's not locked in. All of these are of different ages based on the composition and how far along they are in their development. I think we've seen some of these things, or it's been hinted by some of the observations we've had, where it looks as if galaxies are actually almost giving birth to other galaxies that come popping out. And we've had this discussion about hot Jupiters and what would happen. And we talked about, if the nature of gravity is different inside the solar cavity and inside a galaxy compared to outside, every time you have these pockets of matter that is behaving and glowing, well, as soon as Jupiter exits our solar system, it's going to ignite. It's literally going to become a star, right? And I'm very convinced that this is kind of what all stellar bodies do. They are either crashing into the sun, degrading orbits, or they're actually moving away. Periodically, they can stay for a fair amount of time, almost captured by the nature of the solar wind and the frequency of the actual sun. So basically, the type of sun will decide what kind of pattern of scalar frequencies are in its cavity. So there's going to be almost like lanes where these things can place themselves. But when they place themselves there, they will still keep maturing. The best example is, of course, Earth geology and how that seems to be evolving. We can then get into the whole thing of how would something as crazy as growing Earth even work? Well, it's exactly the same as some of the current models on how stars actually change their nature based on their composition. And
So is this guy going to show us how this thing works?
Well, you can see it here, right? So you have the heating element at the center, and then you pour sugar into that, and then the sugar is heated, and it then is thrown out in all directions. So you get these filaments of sugar. And then any body put in there will then start actually picking that up. Then you can have the discussion of whether it's gravity alone or if it's gravity and electric forces. The point is, if you consider a model that is more like this, that is always growing, that is always able to create new stellar bodies that can either leave the solar cavity or they can actually crash back in, then you have a way more dynamic system, and it explains so much more about the freakish nature of the types of planets that we are discovering now, right?
Yeah.
So it ties back to the same rule that applies to stars, and it's back to whenever you have radiation hitting something that's spherical, the potential exists to create the same internal energy exchange as your stars are basically doing. It's just if it gets a solidified surface because it doesn't have enough energy to heat and glow. Basically, if the plasma becomes too cold, right, then it can get so cool that it creates a shell.
It coalesces.
So there is the same kind of force happening inside the Earth. It's just not at the center. It's at the crust.
Right, right.
And
Yeah,
it's not necessarily fueled by uranium or any exotic matter like that. On the contrary, it's fueled by the same mechanism.
Right.
As stars.
I did a very crude calculation, and actually I didn't do it. I had two friends of mine who are mathematicians do it because I'm hopeless at math. But basically, taking the coronal temperature, taking the photosphere temperature, which is more stable, 5,000 degrees roughly, the penumbra temperature, which is the surrounding of a sunspot, which is about 4,000 degrees Celsius, and then the umbra, the darkest part of the of a sunspot, the interior part, and that's 3,000 degrees Celsius. So I asked both of them, I said, if you continue this this trend downwards, how far down do you go until you reach 0 Kelvin? And they both calculated for me, and it's roughly 3/4 the diameter of our planet. So from the crudest calculation would be that this shell that surrounds our sun, this photosphere, and whatever is below it, has a thickness slightly less than the diameter of our planet.
Well, and again, if you start assuming a completely new model, you do have to go through all of these calculations and why they arise the way they do. I always like to compare the phenomenon of the photosphere almost like a spring layer in water, where you get this shift where the behavior shift is going to be a pause, a lot like the states of matter, where you have this superfluidity-like state where it doesn't behave like it would further away or closer towards the center. The point is still that the cooling is an effect. It's a secondary effect from the nature of the glowing.
Mm-hmm. Yeah. You know, so like, you know, it's so simple when you look. I mean, why does everything have to be made so complicated? You look at the corona and it's like depending on its mood, you know, it's about, you know, 1,000,000 degrees Kelvin, you know, and then then it drops down to the various layers of the chromosphere and so forth, and the temperature keeps dropping down. You get to the photosphere, right? And the photosphere is 5,000 degrees. Now, putting a hydrogen fusion core inside there, you've got a problem. And I've illustrated it with, if you drop the temperature of the photosphere to that of a snowball, so you know, it's 0 degrees Celsius, then you drop the temperature of everything else in accordance with that, you end up with an interior that can melt steel, and you have a temperature outside in the corona that will parboil you. And inside, in this little thin layer, that's a snowball temperature. And you know, that is what they call, you know, the temperature problem of the sun, the violation of the laws of thermodynamics. And it just blows me away that people with a straight brain can go on and believe that this exists like that. And it's just absolutely ludicrous. But, you know, they keep at it, you know, maybe, you know, endless papers, maybe it comes out from the inside of the sun via you know, acoustically, or maybe it comes out with these little spicules that come, and these papers just disappear because anybody who's a scientist knows that that's just not enough. You know, you don't do that. It just doesn't fit. And yet we go gaily on talking about the sun as a hydrogen fusion core. You go to Wikipedia, it's the only model that's offered to you. They all say, oh, and it has its problems. Problems. It's like, that's not a problem, that's a disaster. But, you know, there we are. That's the world we live in.
And this takes me personally back to the fact that all of our cosmology is so biblical and male in nature. Everything has to be about big and heavy and explosive things and colliding things, and it's just so warlike and so fake machismo, and so everything has to come with fuel that can then explode and then can make all these things. It's like, well, if you think about this from a more cyclical point of view, well, then it's more akin to talking about something like the water cycle or the carbon cycle on Earth. All this stuff keeps being reused. And I think it's the same with energy in the universe. The nature of energy is not as simple as the laws of thermodynamics have tried to push into our heads. It's just not really what's going on, because that way of thinking is based on earthbound thinking, where things do actually do that.
Here's the example illustrated. You know, you got corona. Here's the actual temperatures, you know, and here it is if you drop down the temperatures accordingly, and that's what you end up with. I mean, you know, just utterly absurd. Now you were saying about the Now, I'm a big adherent of the laws of thermodynamics. You know,
Well, that's fine. That's fine.
I'm like you don't violate that with the greatest of ease unless you have a
Well, I can
really good
understand that because
explanation.
you're used to living in a universe or in an isolated system where you can claim these things. But as soon as, okay, I'm going to take you back to my well, basically my college days when we were doing thermodynamics and we were doing the calorimeter where with the isolating walls and all this, and now we put ice in water and measure and all this stuff and figuring out specific heat capacity and all that. That's fine, but every single class I've sat through in almost all of chemistry and physics, they almost always say, if we assume an isolated system.
Ah, yes.
And that's your problem. As soon as we start talking about cosmology, you have to throw that thing out because that is a flawed assumption. You cannot say that there is any such thing as an isolated system.
Well, no, I'm not saying that, but in when you look at the photosphere from any angle, from any direction, you know, there's no magic hole other than sunspots that appear in that body. And to me, that says, you know, I'm looking at a sphere. It does all kinds of interesting things. You know, you've got the helioseismology, it vibrates, it produces, well, what sits on top of it, the chromosphere, you've got the corona sitting on top of it. But, you know, the problem that the scientists have with this is claiming something in its center, which just doesn't make sense. In a sealed system, it's like, this isn't a demonstration, like assuming this is a sealed system. This photosphere, aside from sunspots, is a sealed system. And what goes in and what comes out is something that you should be able to observe. So I'm not entirely nixing what you're saying. You know, it's not an enclosed system, and there are sunspots. There is an interaction that definitely occurring in the magnetosphere or the heliosphere of the sun. But in terms of looking at that specific part, it's like looking at this nucleus of our solar system. It's like you know, okay, you know, you've put this boiling furnace inside the sun. Okay, how is it manifesting itself? Oh, but can't explain that.
This was not my point at all.
I know.
I'm talking about the laws of entropy. I'm talking about the fact that someone would like to say that there's this much fuel at the Big Bang. The Big Bang goes boom, and then there's this much fuel, and then it's either going to dissipate into heat death, or it might actually start contracting again because of gravity. But all of these things are these very, as I call them, macho ways of thinking, and they're based on assumptions that I just don't necessarily see any obvious proof of.
Oh, by the way, Jakob, I just want to say a hearty hello to Chris, who's lurking in our background at the moment. And I was just curious, Chris, if you managed to get your microphone fixed at some point, and if you have, come and say hi. If you haven't, well, it's good to see you in on the discussion. And I wish you could comment as well when you get it, whenever you get a chance. Okay, Jakob, do continue.
No, I'm just trying to point out that we are basing so many of these cosmological assumptions, right, on the models that we use for cosmology, on what? Measurements that are what, 500 years old?
Yeah.
On a cosmic scale, that's ridiculous.
Yeah.
That's like trying to figure out how humans work by taking a still image of every person on the planet and then trying to deduce how we work.
Yes, absolutely. I like to draw an akin to, you know, quantum mechanics, which is a beautiful thing, and it's a mathematical structure that encompasses what sort of what's going on in the subatomic world. But here's the kicker. So let's pretend we're gods and we're looking down on Earth and we see things in a different time scale. So when we look at a city, this crystalline structure on the ground, and we notice that it oscillates. It oscillates in a period of 10 like this, does this 10 times, and then it stops for a pause, and then it does it again. And the God scientist says, look, there's an oscillation. We can build that into a calculation. That is what maintains the crystal. And in fact, it doesn't, because what the mathematics don't include is the plumber who goes through, that oscillation is the rush hours. They're watching the rush hours. But that plumber who goes to work at 3 o'clock in the morning, the guy who keeps the sewage system going, it goes to work at 9, like 5 o'clock in the morning. All these little particulates that are traveling, these little electrons zipping down the freeways are like absolutely vital to run the crystal that they're looking at. It's not part of that calculation. So I guess what I'm saying is, quantum mechanics is great, but it ain't it. It's a description of it, and we have to keep that in mind. Just keep it's almost like the Roman victor who is traveling under the Arch of Triumph has a slave on his chariot that says, remember you're human. And in this case here, it's the scientists going through the Arch of Triumph and having this guy standing and saying, remember your epicycles were fucked.
Well, and this goes back to the one thing that I seem to sense that the universe is doing is everything is basically pulsation waves and frequencies. Just a very, very, very complicated nature, right? But this machine does not seem to tire. I don't understand why they insist that it does, just because it will, well, if you start a pendulum on Earth, then eventually it transport and communicates its energies into different types of energies, and then it will stop the thing that you made it do, which is to pendulate and swing. Fine, but on the scale of space, that's just not what I'm seeing. The thing keeps doing it, or it changes into a new nature and then releases some of it, right? This is back to the example of things like the guiding the pilot wave experiment with the bouncing droplet on the surface of water. Well, the universe gives you a lot of those types of energy for free.
Yeah, I know it's sort of come down pretty hard on the Big Bang Theory because it's wrong, but it doesn't mean that there's not something going. Our universe could well be sort of an enclosed system. I don't have a horse in this race. I don't have a pony in this race or a hamster in this race. I don't know, and anything that I would say about this would be on par with you, Jakob. Is there's oscillations and vibrations, magnetic fields that are going on that we just haven't the faintest idea, because we've only been a sentient civilization for as long as we can poke instruments out there and look at it. So there's a lot of fat lady hasn't sung yet. But as far as the Big Bang goes, in our way of looking at it, that's dead. That's just gone.
If you think about it, right? If you take the entropic law to its extreme, right? So let's say everything has teetered out into heat death, right? So now everything is at what you would call the very low energy quality of, let's call it infrared light, right? Let's say everything is like a certain range of infrared. let's even go further and say, well, you have to decide on what is the type of infrared. What's the actual frequency range that everything then gets parked at and ends up as, right? Okay, so we're at that point. So now the entire universe is only filled with that energy. Well, now I only need to do one thing to start the entire universe over, because I've just created a homogeneous universe, just like it was at the Big Bang. Now I just need to change the scale, right? That's the only thing I need to do. I just need to change the scale and say everything just is up a different scale. So now it's going to start over. This is back to the scalar nature of things, right? So I'm basically just zooming out and starting from scratch. So,
yeah,
so
well,
the,
I
so
always
the
did.
argument
I
is
always
fun.
did like that quote in the Marat Sard play. I forget the writer's name. I'm terrible with names. Who says, you know, the important thing is that we turn ourselves inside out and see the world through new eyes. And I just think that's such a beautiful poetic thing to step away from your belief system, step away from your cherished, you know, my subspace sun, and see it through other eyes. Maybe come back to it, but you need to always go out and explore and see things that you even find objectionable, because it may have kernels of truth in it that you need, you know. So you have to remain open and flexible, and even with with the Big Bang, you know, and I look at this edifice, and I do feel sorry for the huge involvement that is in it, and I know it's going to stay there for my lifetime, and probably you guys are maybe slightly younger than me for your lifetimes as well. But it's a system that holds no objectivity anymore. It's based on misinterpretations of nature, and we are finding that out with the James Webb Telescope at this point, and there is no going back. Okay, the peer review papers haven't come out yet, and don't forget who's reviewing those papers are, you know, Big Bang cosmologists. So you got to keep that in mind. But they'll come out. They might be in electrical magazines and stuff like that, and there might be a huge big hue and cry about that. But the jugular vein of the Big Bang has been slashed, to put it in a very rather gross term. You can't walk back from organized spiral galaxies with second generation stars, 180 million light years from the Big Bang, which is just like, for, you know, as I've said, our galaxy rotates once every 200 million years. Well, how do you create a galaxy like that in less time than it takes our galaxy to make one rotation? And it just, the absurdity of it is enough that even a child can see that this isn't going to hold water. So it's on its way out, and there's just nothing else for it. They can insist as long as they want that they can somehow fit it in, and they probably will try and do that. They'll try and fit it in, or they'll try and move the goalposts back so that the Big Bang is further into the event horizon. But it's all rubbish, you know, and they'll have nothing. There won't be a theory anymore. It won't be based on solid evidence. It'll be a hypothesis at that point, and a weak one at that. So this is fertile, as you said earlier on, Jakob. This is fertile ground right now. This is a time when the heretics, the people who've been on the outside, are like, oh, you're joining us now. You're on the outside too. So, you know, it's a new day, and that's what makes all this so exciting. And I should say we're a little bit over an hour. And we should probably pack it in, because otherwise, you know, my poor little computer's going to be grinding away at creating this thing. I wanted to do it before tonight so I can get it out of the way. But this is, thanks for showing the the share screen stuff, Jakob. Really appreciated that, and I do like your approach to the oscillations and how that is like. And I know Chris feels pretty strongly about this as well. You know, this is the structure of our universe. We're seeing just a small part of it, but you know, your intuition says, you know, if you've got hold of the string, you know, the string is going to go somewhere. It's you know, it's fertile ground, and I like that.
The reason it's back to what I mentioned when I said things like the mathematical nature of the universe, and especially on equations that are fractal like in nature, then scales don't matter. It doesn't matter if the universe is 150 billion light years in size. It doesn't matter. It can be 1,000. It can be 15,000. It's really irrelevant because it's all fractal in nature. So it will do the same thing on all these scales. So sure, the range of our current view is 13 point something billion light years. If we assume that the speed of light is actually a constant, which I'm pretty sure there has been plenty of people saying that's a very strong assumption. And the things that we are proposing are saying it is completely bunking wrong.
Mm-hmm.
Yeah, you're
like
Chris.
when you consider.
Yeah, go ahead.
Well, I'm going to say when you consider, you guys can cut me off of this. Like when you go to edit this one, you can cut this off and like just do the short one because I can insulate or whatever. But maybe for next week's conversation, we could talk about what you know, Jakob, you were saying how whether the universe is open or closed, right? And that sort of thing, right?
Yeah.
You know, where you know I see it. It must have a boundary condition of some kind at the very far regions of where it goes to. But what gets me is that you know mainstream science treats the Earth as a closed system relative to that. Right?
But how are you going to map that?
Well, yeah, exactly.
How are you going to map the size and the scale and the nature of the universe? It would be equivalent to sailing blind on the oceans. How are you going to map that then? How are you going
one of the things I'd like to say that Chris brought up last time he was talking was when you get into the macro scale, you know, you're seeing this sort of repeating structure. I found that absolutely
the fractal nature of it, like you know, the perimeter of the UK, for example, you know, can be measured to infinity. Right, it goes forever. It's fractal, and so. My question to mainstream is: okay, you consider the perimeter of the UK infinite, right? At the atomic scale, you can measure that forever, but you won't consider, you know, the universe as infinite or boundless, or is it bound? And then they also, at the same time, they contradict themselves by considering the Earth as being bound and having scarcity, right? Okay, so it's not connected to the universe. It's not connected to the sun.
Yeah,
none of that stuff. None of that light from the stars is entering and adding energy to our
what I get
system.
from that, Chris, is you know, you speak of the macrocosm and you know the Planck length and going down further. And I think you know maybe you know this is the umbilical cord of infinity. You know that it, you know, through the micro to the macrocosm. Does it end? Maybe not.
Maybe not.
Maybe.
And again, personally, I don't think it's important. I'm okay with us deciding that almost like the standard measurements and saying, well, okay, we have this as the Planck length, and we don't want to handle things of scales that are bigger than 10 to the 30 or 10 to the 60. That's fine. I'm okay with that. That makes sense. But we need to acknowledge that just because we have decided that that's the resolution of the universe that we want to work with, and the size of the system, that does not mean that the nature of how this is emerging and the actual underlying rules aren't actually doing that.
Yeah, we need, but like I think we need to decide whether or not we're coupled to it. We haven't even made that decision yet as far as, you know, fundamental physics goes. Are we coupled to it or not? They don't have an answer, right? So if you can't define your starting point, am I coupled to this greater thing or not? It's a simple answer.
I just find it fascinating that so much of the physics that we use, right, the fundamental physics we use, are all really simple, linear exponential functions.
And decoupled from themselves. They're decoupled
And
from
as soon
themselves.
as you look at the space itself, what is it doing? Fractals.
Right. Right. It's coupled.
Hello, why do you keep using the wrong kind of math to describe this?
Right.
Yeah,
As soon as we put gravity at the center of an object and make a sphere out of it and call it an orbit, you decoupled it from everything else. It's now an entity unto itself. It's relative.
Created the isolated system.
You created an isolated system.
By nature of our being human, we tend to do that. I mean, one of the things Chris, involves is, and you, Jakob, are the fractals. But then Chris is also interested in the electrical discharges that are occurring on our planet, which probably is better described with the electromagnetic. Not that it doesn't. Is it though? Gel with the fractals. I don't know what that is, due to my pure ignorance on it. But I think it's the limitation of us little like blood bags with the, with a skeleton as inside of us with the conceit that we think we're trying to understand what the universe is, that, we tend to partition things to probably a greater degree than we need to, but I think much of it is because we haven't found the links yet. I think that's sort of what we're aiming for, and what we're trying to sort of hunt down, so we can pull things together a bit more, because that's the way we understand it. If you think of this like the states of matter, right? And I'm pretty sure that Chris is on the same page. You can say, okay, the simplest form that we can imagine is solids. It doesn't do anything. It's pretty much just stays where it's supposed to be. You've made it behave, right? Of course it does, but we ignore that. The crystal lattices of solid matter behaves. So it's what do you mean by they behave?
Well, everything is stable and everything is locked in place. It stays where it's supposed to. I don't know about that. The other thing is gas.
I would argue.
No, let me finish.
The other thing is gas. That's sitting on a shelf for 400 feet under the ground, and you look at one of
Stephen, let me finish. Let me finish. Everything is locked in a grid in solids. Everything is completely disconnected in gas, right? That's the way we model it. We know that's of course not entirely true, but that's the two models, either completely disconnected or completely locked and connected. But we know that that's not the nature of anything else. Everything else is self-referential. It's like fluids. It's like plasmas. It does not stay put. It does not behave nicely. And even in solids, it doesn't, right? Because then you have the other particulars, elemental particles. You got the electrons, you got the charge, you got all the other things. You got the directionality of the crystal lattices, so it will behave differently to magnetics. All of these things, they're not that simple. We love to simplify these things and lock them in, because then we can use nice linear functions, nice exponential functions, simple functions with very few variables, with very easy constants. As soon as you start having to deal with things like plasma, things like liquid, things like superfluids, now you have something that's self-referential. Now it's a fractal.
Yeah,
everything seems to become a fractal because it all seems to, I think we really need to look at the fractal nature and see if we can get into that somehow deeper, and somehow apply that backwards to the classical equations.
Exactly. It's so complicated because these things don't self-referentiate at nice numbers.
And there's a time factor there too, right? Like if you consider a planet or a star or any other solid material over a long enough period of time, it becomes a liquid.
Exactly.
Right?
Yeah.
Right.
Yeah.
You know, like the windows in a church are actually liquid. You know, consider them over 100 years, you'll see that they're actually
flowing.
they're flowing out. They're flowing out towards the edges and getting thinner at the center. And eventually they'll crack and go egg crackle at the center of the glass and work its way up
That's
to the
true.
center
I mean,
outwards. Right?
what you're pointing out is the time bias that us little blood
Right.
bags have. You know, we are such chauvinists, and it's very hard. It's just part of their nature. We just see things as you know,
So, you know,
inviolate.
time is a function of scale. So that goes back to what Jakob was saying earlier, right? It's the scale.
You know, I'm going to segue for a second. I only recently learned about the in geology, the discontinuity. This is like where there's this, you have these layers of time and rock, and all of a sudden you get to this huge era that's lasted almost 1 billion years, where everything looks like it was just like hit with a blowtorch. It makes
There's 3 of them, actually. It's 3.
Is that right? There's 3 actually. Yeah, so it makes for a great science fiction story. Like aliens come along and they look at what's going on the planet, going, "No, that's not what we wanted." Just sort of take some of the samples of the things that were on the planet, blowtorch the whole thing, and then put those things back again and let them evolve into something else.
And sometimes it turned them upside down. You'll actually see that there's some regions where that you get that KT boundary layer, and it's actually turned upside down.
What the hell is that? You know, I mean, speak of the mysteries of the universe. It's like it just absolutely befuddles me. You know, when I step back and I look at what I know, and then look at what is in existence that I do not know, how it got to be in that state. I just want to lock it away in a cabinet and forget about it, because it's just so over. It's like that way lies madness kind of thing. And I think, again, blood bags, you know, with calcium inside them, we have to sort of, you know, we have to dumb ourselves down in order to be able, to curtail the subjective, which we all have bubbling, by far the biggest part of us. And then this sort of clumsy little construct that's called objectivity that we sort of cling on to and try and sort of like, are you in agreement with this? You're in agreement with this? Okay, let's pretend this is real, you know, and we need that in order. Otherwise, you know, we're just like, you know, we're a disorganized soup that goes nowhere.
I think it's simpler than that. We just need to take what we've actually achieved, especially over the past 50 years with the modern information technology and what we can do with computers, and how we can then visualize things so much easier, right? So now things like deep time is not so crazy. It's not so impossible to understand. I can actually easily go into a modeled universe and say, show me how mountains melt, because they do. They're literally eroded, so it looks like hot water on snowballs, right? It literally just disappears. And the same with seeing things like glaciers move like rivers. All of this can be done when we can play with these time scales and frames. So how big something is, or how fast or slow time moves. And it's the same in the micro. Slow things down. How can we play with that aspect of time? And the other one is the fractal nature of all of this.
Do you think
computers are going to show us all these things? It's going to give us all the solutions.
Do you think that the micro that slows down? I would have thought it would be the other way around. It seems like, you know, you think of ants, you know, or your cellular structure. They're like,
the smaller it is,
they're like moving at a
time is.
in terms of our scale. If you could scale us down and look at them, they're moving at a fucking ridiculous
then you didn't hear what I said. I said the small stuff, I need to slow that down so I can see it.
Oh, so you can see it.
And the big stuff, I need to speed it up
I can see it. Yeah, right. Yeah.
Right. And this is what technology gives us. It gives us these tools so we can do that. and we need to start using them to play with it. And we need to go back to scratch, not try to understand everything based on what we know, but come up with new assumptions and say, what if this, what if that, change the variables, change the scale and what we're looking at. And I feel like we are in for as many surprises in astronomy as physics as we have been in a lot of the more tangible sciences like biology and the evolution of species and all of these things, because shocks kept coming from left, right, and center.
Yeah, I think you're right. I think as we develop more and more better tools that can actually shift that time phase, right? So it's phasing, right? If you develop more and more tools that can jump from phase to phase with their position in time as to when they choose to take a measurement, we'll learn a lot more by changing the measuring stick than we will by looking for new materials, right? Change the stick. We're using the wrong tools.
Yeah, and especially those weird things like when I was I watched that Stephen Wolfram documentary. He's one of my favorite tinkerers and mathematicians. He's the one that did Mathematica and Wolfram Alpha and all that stuff. The point is that he was playing with what he called simple automatons. So it's kind of generational algorithms that have rules that then interact, and they start out looking really nice and smooth, and they behave like almost periodic systems, not really fractals per se, but kind of a little bit in between the chaos of fractals and the stability of a periodic function. But what's funny is that once you get out to a certain amount of iterations of the calculation and permutations, they break down into complete chaos, complete nonsense.
Yeah, one thing we found that when I was looking at some of the research, we put a contest. Jeffrey sponsored a contest for computer programmers that could take what he had done and take it to the next level, to simulate an actual the position, state, spin state, velocities, and so forth of a single atom. And we've pretty much figured out to calculate that with absolute certainty within the bounds of probability theories and all the other stuff, wave functions, right? But to do it to certainty, it would require all the energy in the universe to calculate the position of one single atom, right? So we gave up on the contest. We can't do it. It's mathematically impossible. So,
well, it's those funny phenomena that come out of math when math starts being applied.
Well, see, that proves, that proved to me that, okay, you cannot calculate the absolute position of a single atom in the universe without having all the energy in the universe, or decouple yourself from the universe to actually measure it. You cannot be in what you're trying to measure because you can't be part of the experiment you're in, right?
Exactly.
Yeah, right. So to me, that's where we need to go. That tells me we got to change the tools, right? Because you can't measure it. We have no objective measurement stick to start with, right? So let's start there.
Exactly.
It has to be subjective somehow.
I'm positive when it comes to this. I feel
me too,
we have so many of the tools ready. They're just not being utilized in the optimal way, in my opinion.
Because we gotta do like on a social level, we gotta do something with this Malthus, right? And Arabic institutes and so forth. Somehow we gotta do something with that, because that seems to be creeping up somehow. There's a lot of individuals and a lot of corporations that think, that are starting to think that humanity is a virus or a disease, or we're going to consume ourselves and so forth. So, but in order to kind of conquer that, we need new tools. So my interest is in designing new tools and giving them to people. Right? Here's a new gadget that does something that we never done before. Now go do something with it. So, without getting myself killed.
I realize that there's there are people out there who are. And we're all, I think both Chris and you, Jakob, and myself, we're both normal and we're also at the same time highly eccentric. And this thing, my computer is beeping at me, and I realize there's people who I can communicate with on these subjects quite well, and then there are belief systems that they hold that are just absolutely beyond my ability to understand how they think on other levels. Look, we've been here for over about an hour and a half. So what I will conclude with is saying that ultimately, and inspired by Chris, is that with the macro and the microcosm and time, is we're all dust in the wind.
Mm-hmm. Yeah.
And let's get together. I'm still trying to lure some people into our conversation, and I think I might have some success with it. But both of you, if there's anybody you know wants to join us, I think this could be really fun and enjoyable and successful and constructive. Thank you very much, Jakob, for your contribution today on oscillations and crystal structures. I found that very instructional and inspiring. And Chris, I'm really glad you got to join us, and that you've solved your microphone problem, which is great. And
yeah, like I said, just cut this off the end. You can edit this out the end because I can't so later.
And as far as your image goes, you're beautiful, man. So let's keep get to see the future. All right, guys, I'm gonna go get something to eat. I'll see you guys next Saturday. Okay.
Yep. Later, guys.
All right.
Sounds good.
Bye bye.